Hello, welcome. 4.4b, kite notes. A kite is a quadrilateral with two pairs of consecutive sides congruent, but opposite sides are not congruent. Okay, so we got our consecutive sides, kind of like consecutive angles. Consecutive sides are sides that are right next to each other. So in this case, KI is congruent to TI, and KE is congruent to TE. Okay. One thing you will not see in a kite is parallel sides. If you've got any sets of parallel sides, it is not a kite. Okay. Now there are a few other properties that go along with our kites here, and we'll talk about those as we move forward. If a quadrilateral is a kite, then its diagonals are perpendicular. Okay, its diagonals are perpendicular. So similar to a square and a rhombus, you do have perpendicular diagonals. Okay, so we do get that 90-degree angle there at the intersection of our diagonals in a kite. If a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. Now, in a kite, you should be able to draw, let's see if I can draw a line here. You should be able to draw a line that goes directly down the middle that basically cuts the kite in half and reflects one side onto the other. Okay? In this case, it goes, the line of reflection would be vertical. Okay? Now, because it reflects exactly on top, all right, it gives us a pair of congruent angles. In this case, angle K is congruent to angle T. All right? But you've got to be able to identify that line of reflection because the angles that are opposite that line of reflection are going to be the congruent angles. There's only one pair of congruent angles. Okay? Didn't mean to do that. Hold on. If we take that line of reflection out, I and E, angle I and angle E, are not going to be, okay? Because that's the line of reflection goes through those two. In this example, it's harder to see, but you could do a really extreme example of a kite that looks something more like this. We'll make it go sideways too, where you got a kite that's really wide on one end and then skinny on the other end, where you got your congruent sides up here, congruent sides here. Well, these two angles are not going to be the same, but these two would be. Okay? And that always happens with our kites. So our kite definition, a quadrilateral with two pairs of consecutive sides congruent, but opposite sides are not congruent. Two theorems: if a quadrilateral is a kite, then its diagonals are perpendicular. And if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. Okay? So you're going to have some problems, and a lot of times they deal with angles with our kites. Here's one where we're trying to find the measure of KIT. So angle KIT. So we're trying to find this whole angle up here. And TEK. TEK, we're trying to find this angle down here. All right. Now, we're going to use the fact that we've got a kite and diagonals are perpendicular. So we can look at these triangles, and we're also going to look at the fact that it's symmetrical. Okay, it's symmetrical. So if I want to find this angle KIT up here at the top, all I need to do is find one of the sides, okay, and then double it, because I know that these two angles, the two small angles that make it up, are congruent. I'm going to use this triangle here. So we've got this triangle right here. It's a right triangle. We know two of the angles, 90 and 38. Add them together, we get 128. If I subtract that from 180, I get a 52-degree angle. Okay, that 52-degree angle goes right here. Well, to find angle KIT, I just double that because this whole triangle reflects over and becomes this triangle, which is 38, 52, 90. Double these, 52 plus 52, we get 104 degrees for angle KIT. All right? Now, from this point, there's actually a couple different ways we could solve for angle TEK. Because we found angle 52 here, we could actually look at, let me change my color. We could look at the really big triangle, and I also know that that's 38 because this is 38. But we could look at the really big triangle. And we know two of the angles, if once I add these together, 38 and 57 is, what is that, 95? So we got a 52-degree angle, a 95-degree angle. We could find this angle down here using those three. We also could go and use, just like we did up here, we could look at the smaller angle that has 90 and 57, which is 147, and subtract that from 180. And that does give us, is that a 33-degree angle? Which makes this a 33-degree angle because we know it reflects over that line of reflection. So that makes angle TEK 66 degrees. The thing you just have to be careful is you need to be able to identify that line of reflection, okay? And that line of reflection, when you look at it on opposite sides, you'll see the matching, corresponding, and congruent sides directly across from it, okay? So this side and this side have to be directly across from that line of reflection. The double hash side needs to be directly across. And that's going to help you figure out which angle is going to be the congruent angle and which two are not. The two that fall along that line of reflection are not going to be congruent with each other. Okay? That's the last example we have here. I do want to let you guys know that there is a system of equation problem on your homework. Okay? There is one of those on your homework, and you just need to be careful about how you set up your two equations that you're going to be using. All right, and let's see. What you're going to be using is you're going to be given lengths for, you're going to be given expressions, something similar to this, like x for this and 2y minus 5, 5 for this, 3x plus 2, and 4y plus 1, something like this. But you're going to be able to set up an equation using your sides that are congruent, your consecutive sides. So you could get x equals 2y minus 5, 4y plus 1 equals 3x plus 2. And then with that equation we've got set up here, you're going to be able to substitute 2y minus 5 in where you see x. So in that second equation, you'll get an equation that just has one variable, and you can solve for it. Similar to like we did in the last problem on the square edge elastic assignment we just completed.